Good day. Welcome to our lesson. On this lesson, I'll be attempting Gauteng grade 11 Maths paper 1 paper from November 2023. So without wasting any time, let's go straight to the first question. On the first question, it was an algebra question. So we were given an expression for k. So we're being told what k represent, as you can see there. So we're being told that k is equals to square root of 5 over p plus 2 and then plus p over 3. So then first question, we are being asked to show that k is rational if p is equals to 3. So in other words, we just need to go there and wherever you see p, we're going to put 3. So on the given expression, we know that k was equals to that. So k, we know it was equals to square root of 5 over, and then now we have been told that p is 3. So meaning there, instead of putting p, we're going to put 3. So it'll be 3 plus 2 there. And then plus this side, again, we see p. So instead of p, we're going to have 3. So it'll be 3 over 3 the other side there. Wherever you see p, you put that. So from there onwards, you can just put everything as it is. So it will be square root of 5 over 3 plus 2, which will be square root of 5 over 5, yeah, plus 3 over 3, that will be 1. So this will just come back as square root of 5 over 5, which will be 1. So you're going to have come back with square root of 1 here. And then the plus the other side, 3 over 3 will also come back as 1. So you can just put the whole thing as it is once if you want to save time. So square root of 1, we know it's 1. So 1 plus 1 will be 2. So the answer will be 2. So basically when p is equals to 3, and then the k becomes 2. That will be the answer for the first one. So let's go to second one. For which values of p will k be real? So they're asking us now, which values of p will k be real? So to solve this type of question now, we must ask ourselves, so far we know that for real numbers to exist, for example, if you divide 5 by 0, for example, any number divided by 0 is undefined. So meaning it can't be a real number. So if we to divide this number here 5 by 0, therefore the number won't exist. And the only way we can have our denominator here as 0 is if we can get a p which will be, for example, if you get a negative p, let's say we got negative 1 as our p, and then that will give us a number that will still be positive. So in other words, for us to get a number that will allow us to define the whole thing, the other way you can solve this type of question is we can actually transform our p, just put 1.1.2 here. So we can transform our p and make it a positive number. So for example, p plus 2, which are the numbers which are on the denominator, they must be above 0 or greater than 0. The number that we're getting there must be above 0. So whenever you've got that whole expression is above 0, you can try to solve for p again. If we were to take p the other side, therefore so 2 the other side will become negative 2. So meaning p will end up being greater than negative 2. So the only way you can have k as a real number is if p is above negative 2. The reason is if p is negative 2, for example, negative 2 plus 2 will give us 0, meaning to be 5 over 0, which will be undefined. So p must be above negative 2. So p can be any number which is above negative 2, then the k will be real numbers. So that will be for 1.1.2. So I'm trying to erase this part here so that I can get some space now. Trying to get some space to solve this type of question here. Okay, so now we're going to solve for x. So the first thing that we're being told now is that okay, we're given a trinomial. So they're giving us a trinomial. So the trinomial that we're given, they're asking us to correct to 2 decimal place. So we know every time when you see the word 2 decimal place, we automatically think about the quadratic formula. So for example, here on 1.2.1, so we know we're given 3 expressions for a trinomial. We're given a there, we have b there, and we have c there as our trinomial. So we check everything is in order there. Wait, is that whole thing equals to 0? Because we're given 3x squared. Because remember, for a trinomial, the whole thing must be equals to 0. And what I'm seeing here is that it's not equals to 0. Oh, yeah, I think, yeah, it's not equals to 0 actually. It's written in this way. I think the thing that I got is not clear. So we're given it as 3x squared. So we're giving it as 3x squared. Let me try erase that. So we're giving it as 3x squared. So they give it to us as 3x squared. And then the whole thing was equals to 4x plus 2. The whole thing was equals to 4x plus 2. 4x plus 2. That was a given problem. So we know that you must have a trinomial. So to have a trinomial, you must put everything in order. You must have a, b, and c. So this one is already on the left side, so I'll keep it on the left side. Then I'll take the other ones to the right side, meaning it will come back as minus 4x here. So it will come back as minus 4x there. And then when I also take the 2 the other side, it becomes minus 2. Then the whole thing is equals to 0. So then now that becomes our trinomial. That whole thing becomes our trinomial. So we know once you get a trinomial, we're going to have a as the first number. So our a will be the first number there, which will be 3 now. So a is 3. B we know is going to be minus 4. B will be minus 4 there. That will be B as minus 4. And then lastly, C will be minus 2. C will be minus 2. So that will be our trinomial like that. A, B, and C. So once you get all those 3 values, just need to go and put them in the quadratic formula as it is. Then that will give us the 2 required values now. Just need to go and put everything as it is on the quadratic formula. So from there onwards, now that we've got our A, our B, and C, we're going to put everything in the formula. So I'm putting all the values in the formula and see how much that will give me. So I find which 2 values are we going to get now. So I put everything in the formula and see which 2 values we're going to get. Okay, I put everything in the formula and I got 2 x values now. So the first x value that I got there was 1.72. So I got 1.72 as the first one. And then the second one, just put R there. The second one that I got, x is equals to, so I got negative 0.39. So please comment in the comment section if maybe you're getting different values. So I got negative 3.9 as my second value. So if you're getting a wrong or different value, please comment in the comment section. Sharp. That is for 1.2.1. That is that. Those will be the 2 x values for the 2 mark. So let's finish off with the last one now, which will be 1.2.2 now. So let's do 1.2.2 now. So for 1.2.2, again we're solving for x now. So we're solving for x again. So let's just go to 1. So now we are doing this one. So on this one, we're given our number as x squared plus 10x now, plus 10x, and then the whole thing is greater than negative 21. The whole thing is greater than negative 21. So again, the same thing applies. We can get it as a trinomial. So to get this as a trinomial, we're going to put everything in one side. So meaning you're going to have x squared there, which is already that side, and then plus 10x now. So we're going to get that everything into one side. So it will be plus 10x there. So it will be plus 10x there. And then we're going to take minus 21 the other side. So it becomes plus 21 on the left side there. It becomes plus 21. and then the whole thing will be greater than 0, there. Again, we have a trinomial. So whenever you have a trinomial, same thing applies. We've got A, B, and C. So for those ones who are comfortable factorizing, you can factorize, or you can use the quadratic formula to get the two factors. So I'm going to put my two factors here. So when I factorize this whole trinomial, or you can use the formula to get the two x values. So if I were to factorize this, I'm going to open the two brackets. I'm going to open the two brackets to factorize this. I'm going to open the two brackets, and then the whole thing will be greater than 0. So to get the two factors, check the third number is 21. Two numbers, if we multiply, will give us 21, and if we add them or minus them, will give us 10. So it's 7 and 3. So the two numbers that will give me 21 and also 10. So it's 7 and 3. So already we know they're all positive, so we'll just come back as x there, and then because it's positive, will become plus there, and then another one also will be positive, so it'll be plus as well. So this will be my two values, x plus 7 and also x plus 3. So from there onwards, we can get the two critical values. So my two critical, so we're gonna call those two values we are getting our critical values there. So the first one, if you were to solve this for x plus 7, it will be equals to 0. So meaning the first critical value we'll be having here will be minus 7. Then the second one will be same thing, x plus 3 equals to 0 will give us a critical value of minus 3. So when you do the number line, always do it from the smallest number to the biggest number. Negative 3 is bigger than negative 7. That's why we start with negative 7. So always start from the smaller number to the bigger one. So because, as we know with parabolas, if the value of a is positive, you always do a smiley face. You're going to put a smiley face like that between the two critical values there. So from there onwards, we check the given sign. The given sign on the problem was greater than. So because we're given a greater than, we need to find, we call this line that we have a 0 line. So we need to find where the given or the drawn graph is above the 0 line. So our graph is above the 0 line from here. This whole region here. This whole region is above the 0 line. Same thing applies. This whole region is above the 0 line. Yeah. So now we know this graph of ours is above the 0 line before negative 7. So whenever you're saying before, we use less than for before. So meaning x will be less than minus 7, because we use before it become less than. Also, our graph is above the 0 line after 3. So after negative 3, so meaning after will become greater than. So meaning also x will become greater than negative 3. So this would be my two x values that they're asking us to get. So that will be the final answer, where x will be less than minus 7, at the same time will be greater than negative 3 now. So that will be that. And then let's move to the next question. We're still in solve for x. So let's go to 1.2.3. So for 1.2.3, we're given square roots. So we're given square roots there. So whenever you're given square roots, we know that whenever you're given a square root, we can take out the square root there. But before we do that, just put the whole thing down here. So we're given a square root there, and it's x squared. So we're given x squared, says x squared minus 5 now. So I'm going to put everything into order. It's x squared minus 5, and then outside, and then we've got equals to, the whole thing is equals to 2 root x then, 2 root x. That's our given expression there. Just put my x, nice. Took some right, I'm writing 2 c's now. So it's x there. So I'm gonna put x there. Okay. So we know that to take out the square root, we normally square both sides there. That's one best way to take out the square root. So we'll square that side. Also, whatever you do on the left, you do on the right now. So you're gonna square both sides. So after I square this side, we'll be left only with x squared minus 5 now. So we'll be left with x squared minus 5 there. And then the other side, we're going to the square that we're having outside will affect everything. For example, this squared will affect the 2 first, so it'll be 2 squared. 2 squared will come back as 4 now. So it'll be 2 squared that will come back as 4, and then you're gonna put a dot for multiplication. Again, the squared will affect square root of x, and you know that whenever you use a square root, the squared will take out the square root, meaning here only x will come back, because square root of x squared will come back as x. So I mean this whole thing will just come back as x. So from there onwards, you can just simplify this whole thing. So we've got square x squared there, and then we've got minus 5 there, and then the whole thing 4 times x will come back as 4x then. That'll be 4 times x will come back as 4x. So from there onwards, we can just arrange everything to become a trinomial now. So already I can just make it a trinomial, so meaning it will be x squared there, and then minus 4x that will come there, and then minus 5 is already there like that, so it's fine. And then the whole thing will equate to 0 now. The whole thing will equate to 0. So whenever you have a trinomial, again, if you're not comfortable with factorizing, use the quadratic formula. If you're not comfortable with factorizing, use the quadratic formula. But if you can factorize, you can factorize. But if you're not comfortable, I always advise us to use the quadratic formula to get the two x values. It will make your life easy if you can factorize, because if you spend time trying to factorize now, you end up losing a lot of precious time. So with factorizing, we've got minus 5 there. Two numbers, if we multiply them, they'll give us minus 5. It's 1 and 5. It'll be 1 and 5. Those are my two numbers, 1 and 5. And they'll also give me 4, so that's fine. So the two numbers we're going to have. So now I need to find the sign. It's minus 5 there and minus 4 there. So meaning here it will be plus, and then here it will be minus, because 1 minus 5 will give minus 4. It's fine. So meaning we're going to have x plus 1 equals to 0, which will come back as x is equals to minus 1. So it come back as x is equals to minus 1, and then we know minus 1, or the other one will be giving us x is equals to 5 now. So x is equals to 5 there. So once you get those two x values, you need to go and prove or test them. You must test them and see if they are both correct or not. So let's test them. So we test them on the given expression. So let's first test minus 1. So when you test minus 1, you go to the given expression. Wherever you see x, you put minus 1 there. So in other words, it will be square root, open a bracket, minus 1 squared, then minus 5. So whatever you have on the left should be equals to what you have on the right. So let's find out what we have on the left side. So the square root of negative 1 squared will be 1. So in other words, on my left side, I'm going to have square root of 1 minus 5, which would be negative 4. And we know in maths, you can't have square root of a negative number. Square root of a negative number is undefined. Don't forget that. So meaning x cannot be negative 1. X can't be negative 1, because whenever x is negative 1, then we end up getting a square root of a negative number, which is undefined. So x can be negative 1. Let's test x is equals to 5 now. So it will be, wherever you see x, you put 5. Let's do the left side first. So we're going to come on the left side here. It will be square root of 5 squared, which is 25. 25 minus 5 will give us 20. So it will be square root of 20 on the other side. And then we come the other side, square root of 20 on my left side. On my right side, it will be 2 square root of 5. Let's see if they'll give us the same value. 2 square root of 5. Just 2 square root of 5 and square root of 20. Yes, I'm getting the same values. So meaning x is equals to 5. So the only answer that you can get here is x is equals to 5. X can be negative 1. So when you make a conclusion, you must make it clear that x will be 5, not minus 1. So that will be that one for the first one. So we're done with that one. So I want to quickly also go to 1.2.2 now. 1.2.4. So I'm gonna go to 1.2.4 now. Now that I've solved that one, 1.2.4. Hope the color will be visible there. I think it's visible here. So let's go to this one now. We're given this whole with exponents and all that. So let's figure out what's given to us. So given 3 to the power of x plus 1 plus 3 to the power of negative, so to the power of x minus 1 is equals to 10 over 9. So whenever you're given it like this, first thing that you always do is to expand it now. So when you're dealing with exponents, if you're given like that, you must expand it. So by expanding it, you go back to what you know with exponential rules. So 3 to the power of x plus 1, the same thing as 3 to the power of x times that. Same thing applies with this one as well. We just need to expand it again. So it will be 3 to the power of x. And then there we are having negative 1. So it will be same thing as 3 to the power of negative 1. So whenever you are given like that, just need to expand it backwards. And then the whole thing we know is equals to 10 over 9. That's what we have on the left side. Okay, fine. So from there onwards, we can use the common factor. Our common factor that we're having there would be 3 to the power of x, because it's occurring twice. So whenever we have a number that's occurring twice, we use it as a common factor. So it will be 3 to the power of x there. And then when it goes to itself, it's 1. So it will be 1 times here to come back as 3 to the power of 1. Then you close the bracket. And then, no, you don't have to close the bracket actually. Just add the whole thing once. Let's add the whole thing once. So it will be plus there. Again, it's 2 to the power of x. We know it's going to be 1 times 1 times 1 times 3 to the power of minus 1 there. And then the whole thing, we close the bracket. And then on the other side, we've got 10 over 9. So yeah, that allows us to do that. 10 over 9 there. Okay, fine. So I just need to get the number that you are having inside here. You can find that in the calculator. Same time, that will save us time. So it will be 3 to the power of x, which is there outside there, and then the number on the bracket. What are we getting? Yeah, I'm getting 10 over 3 now. I'm getting 10 over 3 there in the bracket. I'm getting 10 over 3. Then you close the bracket. Then we have other side, we are having 10 over 9 now. We have 10 over 9 the other side, 10 over 9 the other side. So from there onwards, yeah, the aim is solve for x. So you will divide both sides by that. Okay, let me just erase this one. Let me erase this one so I can get some space there. Let me erase this so I can get some space. Let me erase that so I can get some space to solve this one. The aim is to get some space to solve. Okay, so you're gonna divide both sides by 10 over 3 now. So meaning you're gonna end up with 3 to the power of x, that is the remaining side, will be equals to 10 over 9. So it will be equals to 10 over 9 now. 10 over 9 divide by 10 over 3. Divide by 10 over 3. That's what we're going to end up with. 10 over 9 divided by 10 over 3. 10 over 3. And then from there onwards, 3 to the power of x will be equals to what we're going to get as 10 over 9 divided by 10 over 3. We get that. Let's see how much that will give us. 10 over 9 over 10 over 3. Yeah, it's giving us 1 over 3. We're getting 1 over 3 now. So that's giving us 1 over 3. And then from there onwards, we can just take that one upside down now. So it will be 3 to the power of x. And then 1 over 3 is the same thing as 3 to the power of negative 1. The same thing as 3 to the power of negative 1. So we know in exponential laws, same base, we equate the exponents. So meaning our answer will be x will be equals to negative 1, because we've got the same base. So meaning it must be the same exponent. So it will be x is equals to negative 1. That's our answer for that one. Perfect. I think that covers that. Yeah. So now let's go to 1.3, where they're asking us to solve for x simultaneous. Okay. So let me erase so I can get some space there. Let me erase this so I can get some space for that. So I can get some space for 1.3 now. For 1.3. Okay, fine. So doing 1.3.1 now. 1.3.1 now. Solve for x and y. Okay, remember when you're given two expressions, so we know that the first one was number 1. That will be number 1. That will be number 2 next. We're given those two as our two expressions. So we need to change one that we can easily change. One which will have fractions or squared and all that. So that this one that we have here, it's easy to change. So we can just make x our subject there. So if I make x subject, everything else will go to the right side. The meaning to come back as x is equals to, everything else will jump the bridge. Already I've got 2 there. So it will be 2 minus y, because y will jump and become minus y. And then this one will become my third equation. This becomes my number 3, which you've changed, becomes number 3. And then from there onwards, you're going to sub number 3 in the other one, which is number 2. So you're going to sub number 3 in number 2. So we're going to sub number 3 in number 2 there. So we're going to sub number 3 in number 2. So we're going to sub number 3 in number 2. So now we're going to check now our number 2. Wherever you see x, you're going to put that. So far we are having y plus 1 other side. So wherever you see x, you're going to put that whole new number 3. So it's y plus 1 there. And then the whole thing is equals to is minus 3 there as the numerator, and then the whole thing over x. So whenever you see x, you're gonna put the whole number 3. Number 3 is this one. So whenever you see x, you're gonna put that as your number 3. So it will be 2 minus y. That's our new x. 2 minus y, and then you close the bracket, the 2 minus y, and then also there's still minus 1, which was there before. Just put an x as a new number, but then the minus 1 was there before. So that is fine. So from there onwards, let's just simplify that whole thing. So they become y plus 1, and then the whole thing will be equals to minus 3, minus 3, and then over 2 minus 1 will be 1, and then we'll be left only with negative y, sorry. So left only with negative y there after cleaning the whole thing. So that's fine. So from there onwards, we also know, also if you're doing physical science, whenever you've got a number like that, we can do what we call cross multiplication. The one there will multiply that one, mean this one will multiply that one. So when it's like that, now the whole thing will just simplify to this. So the whole thing will simplify to this. So the whole thing will end up simplifying to this. So it will be that times that. So y plus 1 times so okay, and I will just put them in brackets. So it will be y plus 1. They're multiplying each other, those two. So it will be y plus 1, and another one will be 1 minus y. 1 minus y. There are two of them multiplying each other, and then the whole thing will be equals to negative 3 times 1 will come back as negative 3 on the other side. Okay, so from there onwards, we know with grade 10, these two will multiply each other first. Y times 1 will come back as y, and then again y will multiply negative y, which will come back as negative y squared, come back as negative y squared, and then 1 times 1 will come back as 1. So this will multiply, and then lastly 1 times negative y will come back as negative y, and then the whole thing you equate to minus 3 there, equate to minus 3 there. Okay, so from there onwards, we can do the like terms. Let's see which like terms we're having. Y minus y is 0. So y minus y will come back as 0, meaning we're left only with negative y squared there, because y minus y is 0. And then we also have got 1, which will come there. It will be plus 1 there, plus 1 there. And then negative 3 will jump the other side, which will become plus 3 if we were to do that. Just leave it aside. because I feel like it will just be unnecessary now, because I wanna, yeah, just leave it aside just to avoid doing a lot of jumping up and down. So just come back as -3 as it is now. Come back as -3 as it is. Then it will become -y squared there, and then it will be 1 can go other side, so it will be -3 there, minus 1, -3 minus 1. So the aim is to, yeah, you can make y positive there, so it will be y squared as positive. Divide other side also by -1. So if you divide this whole thing by -1, just come back as -3 minus 1 is -4. -4 divided by 1 will come back as 4. So the whole thing will just come back as 4. Positive 4. So I divide this by -1 so that it can come back as this now. So divide this one also by -1 so that everything, you divide both sides by -1, then it will come back as y squared is equals to 4. And then we know in maths the aim is to solve for y. If you have got a square, you can just do square root. Then if you square both sides, it will just come back as y will come back as, whenever you do a square root in maths, it's plus or minus there. So whenever you do a square root in maths, it becomes plus or minus. So meaning to become plus or minus square root of 4, which is 2. So meaning y now will become 2 or -2. So y becomes 2 or -2. Those are my two y values. So y will become 2 or -2 as the two y values there. And we know once we get the y values, we can find the x value. So to find the x value, we can use number 3, which we had already. So it will be x is equals to 2 minus y. But the aim is to find x now, so it's 2 minus our y value now. On the first one is 2. So meaning whenever y is equals to 2, x will become 0. So it becomes 0. Same thing applies here. Same thing when I use number 3 again to find x. It will be x is equals to, we've got 2 there minus on number 3 now. And then now we know y is -2. So because it's -2, you put a bracket of -2 now. So 2 plus 2 will be 4. So meaning x is 4. So whenever y is -2, x becomes 4. So that will be our simultaneous answers. X is equals to 0, x is equals to 4, and our two y values. Okay, fine. So I think that covers that. Yeah. So without wasting any time, let's do 1.3.2 now. Hence or otherwise, determine the values of 1 over x plus 1 over y. Okay. So let's find those values there. 1.3.2 now. So one has to find values of 1 over x and 1 over y now. So it's only 2 marks. So the good thing is that we've got x and y here for 1.3.2 now. So remember, we can use we know that here, for example, we can use, if I use x of 0, remember any number over 0 is undefined, so I'm going to use the second one, because the second one is having nice values. So here we know we've got y of -2 and x of 4. So open a bracket, it's 1 over x. Our x we know we found it as 4, so we're going to use x as 4. And then plus, when x is 4, y was -2, so there'll be 1 over -2 there. And then you can just put everything as it is on the formula sheet to find the value of that. Just put that in the formula sheet. So run the formula sheet in the calculator and find the value of that in the calculator. And see how much that will give us. 1 over 4 plus 1 over -2. I'm getting 1 over -4. So that will be the value that you get if you are 1 over -4. So that's the value that you get if you use these values that you got here. Because if you use x of 0, the whole thing becomes undefined. So the only way it will exist, this part won't exist because 1 over 0 is undefined. So only this part will exist to find the value of. So if you use this one here, you won't get a value to be undefined, but this one will give us a value which is 1 over -4. Okay, that is done. Move on now. We're going to 1.4 now, which will be nature of roots. So we're given an expression which is 2mx squared minus, open the bracket, m minus 2 close the bracket x plus m plus 1 equals to 0. M is not 0. Determine the values of m for which the expression will be real roots. So the others to find where it will be real roots first. So one thing for sure, you know about discriminant. So whenever you see nature of roots, you must start thinking about discriminant. So discriminant, we know from the formula itself that it's b squared minus 4ac. So it's b squared minus 4ac. That's what we know about discriminant. It's b squared minus 4ac. So that's telling us that determine the expression for when the roots are real. So for roots to be real, we know that the discriminant must be greater than or equal to 0. That's when the roots are real. That's what we know. So meaning this whole thing that we're having must be greater than or equals to 0. So now we know b is the number next to x. So your b becomes m minus 2. That's the number before x. The number before x squared, which is 2m, becomes your a. Then the last part, which will be m plus 1, becomes our c. So our a will be 2m. That will be the number before x squared. The number before x is m minus it's not m minus 2, it's negative m minus 2 before x. So now I'm going to put these values as they are on b. So I'm going to start with b squared first. So meaning b squared, we know is the number before x, which is negative. It's negative, which is outside. So I'm going to put it as it is in the given expression. So it will be negative outside, and then m minus 2. That will be our b squared. That the whole thing becomes our b squared. So just close that and put an x squared there. Just open a bigger bracket there and put that as x squared there. And then minus, we're going to go to 4 now. 4, it will be 4 there times a is the number that we have before x squared. And a there we know is 2m. So because I'm multiplying, I'm going to put 2m. A is 2m. Close the bracket, and then you multiply that with c. C is the last number, which we are having it as m plus 1. C we are having it as m plus 1. C we are having it as m plus 1. And then the whole thing, remember the roots are real. So it will become greater than or equals to 0 because the roots are real. If the roots were non-real, it would have been less than 0. But because the roots are real, it will x greater than or equals to 0. So that will be that. So from now onwards, you can just simplify this whole thing. The minus is there outside, but the whole thing is being squared. So because the whole thing is being squared, that will eliminate the negative outside. So meaning, if it was to simplify this thing now, it will just come back as m minus 2 there. So the negative will be gone. So it will come back as m minus 2 there. And then you're going to square that. And then minus 4. This one I can multiply is, so it's going to be 4 times 2m. That's 8m. So it will be 8m because 4 times 2m is 8m. And then we know that we're going to multiply that with, let's just do it step by step. We're going to multiply that with m plus 1. So I'll multiply that with m plus 1 so we don't end up doing a lot of multiplications at the same time. So it'll be m plus 1 there. And then the whole thing is greater than or equals to 0. So from then onwards, let's expand this. M minus 2 times m minus 2. So if, because it will come back like this, for those ones maybe not comfortable with expanding, so it's m minus 2 squared. So it will become m minus 2 there, and same as m minus 2 again. And then the same thing that we do of simplifying will apply. The first m will multiply the other m the other side. So m times m will come back as m squared. So it will come back as m squared. It will be this m here. We'll multiply the m there first, and then second, the m will multiply the negative 2, which will come back as negative 2m. Will come back as negative 2m, and then negative 2 times that will come back as negative 2m, and then negative 2 times negative 2 will come back as positive 4. So, and then that will be that when you simplify that. And then here it will be 8m times m will be 8m squared. That will be 8m squared. Then Negative 8m times 1 will come back as negative 8m. When you simplify that, and then the whole thing will be greater than or equals to 0. Okay, fine. So now let's simplify the whole thing. M squared, or like times, let's do like times. We've got m squared here minus 8m. Those two are like times, so it will be m. So it'll be the same thing. I come back as m minus 8m. So m minus 8m will come back as negative 7m. So it will come back as negative 7. Same thing as 1 minus 8 will be negative 7m squared now. Negative 2 minus 2 is minus 4. Minus 4 minus 8 will come back as minus 12m. Will come back as minus 12m. Negative 4 minus 2 will come back as negative 12m. Then lastly is numbers. It's 4. 4 is by itself. So 4 will come back by itself. So 4 will come back by itself there. And then the whole thing will be greater than or equals to 0. So will be greater than or equals to 0 as our simplified number. So from there onwards, you've got A, B, and C now. So we've got A, B, and C as our lovely number. So if you want to make, because I don't like working with negative A, so let's divide everything by negative 1 now. So if I divide everything by negative 1, this will come back as 7m squared. But if you want to use the formula, you can use the formula, but I'm not factorizing. So I'm going to divide everything by negative 1. Also this one by negative 1 will come back as 12m now. And then 4 by negative 1 will come back as negative 4. And then the sign now will change. It will become less than or equals to 0 now. Whenever you divide or multiply by negative, the sign must change. So now we've got that whole thing now, which I can factorize. Yes, I can factorize that. But I can't factorize it when A is negative. I don't like doing that. But I can do it when it's like this now. So we know that it will be, it's 7m. I can have m the other side now. The other side I'm going to have m here, because that can give us 7m squared now. So we've got 4 as the third number. The two numbers that will give me that would be 2 and 2. I'm going to use 2 and 2, because 2 and 2 can give me 12 in the middle number there. And then it's okay, other one will be negative, other one will be positive now. But then if those ones are not comfortable with factorizing, I think you can just use the quadratic formula. It will make your life a bit easier. Once you've got A, B, and C, it will give you the two values that you're looking for. So here I know that to be 7m, so meaning m, same thing applies of critical values there. So please allow me to erase here, because I'm running out of space. So I'm going to erase this whole part now, so that I can get space to finish up this last part now, where I'm going to show you guys how to find the two remaining values. So I'm going to do the same thing I did before of critical values there. So here, if we're going to have a critical value, the other one will be minus 2. So we're going to have minus 2 for m plus 2 there. Then the other one we're going to have 2 over 7 there. So remember, don't forget, you go from lowest to the highest there. And then now because m is positive, you put a smiley face there. And then the sign now is less than. Less than is below. So you're going to focus below the 0 line. This is our 0 line there. Don't forget our 0 line. So because it's below, you're going to have to focus on this whole side, which is below the 0 line. And we know that the graph becomes below the 0 line after negative 2. So meaning, because it's after negative 2, m will become greater than or less than minus 2, because it's after negative 2, but it's before 2 over 7. So meaning or m must be less than that. So meaning m will be less than or equal to 2 over 7 as my two m values. So those will be my two final m values for that question. So that covers that. So my two m values will be that, based on that. Okay. So now let's move on to next one, 1.4.2. 1.4.2, they're telling us that find the two real roots that are opposite in sign if m is less than 0. So the two roots which are opposite in sign if m is less than 0. So if m is less than 0, okay, that's fine. Oh, but here we're told that m can be 0. Okay, m we know is, those are my two m values. So if m is less than 0, okay, we know we've got a, b, and c. Ne? So we've got a, b, and c. So let me just do 1.4. We've got a, b, and c. So if m is less than 0, therefore you'll expect your c to be above 0, ne? Because our c before was m plus 1. So if m is being less than 0, you can expect c to be above 0, because that would be negative 1. Okay, that's fine. Yeah. So c will be above 0, and then c we know it was m plus 1. So c we know it was m plus 1 that we were given in the equation. So it's m plus 1 there, and then greater than 0 there. So if we to simplify this, it will just come back as m will be greater than negative 1. So m will be above negative 1. So meaning m must be greater than negative 1. Yeah, m must be greater than negative 1 for that to apply. M is less than 0. So m must be above negative 1, but must be less than 0. So m is greater than negative 1, but we know it must also be less than 0. So the two ways that will solve that. M will be greater than 1. At the same time, m is less than 1, and less than 0, sorry, as we were told in the given question. Okay, now let's go to question number 2, where we'll simplify without the use of a calculator. Okay, we're not required to do the calculator. So we're given that whole thing now to the power of negative 1 over 3. It's 512. So if you go to the calculator now and do 512, just do it step by step with you guys. You do 512 and then you do shift fact to give us two values. So you do 512 equal to, then do shift fact, because I'm changing 512 now. Because the aim is to change those two numbers now. Let's change 512 first. So 512, when you simplify it, if you do 512 shift fact, that will give us a number. Or we can just change it normally. We don't have to do shift fact. Just need to find a way we can change this to 2. 2 to the power of 3 is 8. Power of 4 is 16. Then it goes 32. Yeah, 512 applies to 2. So let's find out which number am I going to apply exponent 2 by, because it does apply 2 to the power of something to 512. Let me just test them quickly. 2 to the power of 6. No. 2 to the power of 7. No. 2 to the power of 8. No. 2 to the power of 9. Yes, 512. So 512 is 2 to the power of 9. Fine, that works for us. And then we know it was x to the power of 3. Just put a bracket there. And just do it as it is. So it will be 2 to the power of 9, which is 512 there. And then we know we had x to the power of 3 there attached to that. And then that whole bracket must go down, because we need to change the other one as well. So then you divide that. We have 64 now. 64 we know is 2 to the power of 6 there. 64 we know is 2 to the power of 6. And then it was attached to x to the power negative 3 this time around. And then there was an exponent outside of negative 1 over 3 there. So that's fine. Negative 1 over 3 there. Okay, so we've simplified that now. So now that we've done that now, this can make our life a bit easier now. So we know with exponential laws, if you've got the same base which we have of x, I've got the same a base of x there and a base of x there, and also I've got the base of 2 and a base of 2. So whenever you've got the same base dividing we minus the exponents. So meaning this will just come back as 2 to the power of 9. Same base, we minus the exponent, minus 6, because 2 is the same base there. That's fine. And then the whole thing will also be attached to x. X also same thing, same base. We've got 3 there, minus the one that is coming from below is -3 now. Just be careful of that. And then you close the bracket there. And then the whole thing, remember, we're still in a bracket because it's still being attached to negative 1 over 3 and it's still being attached to negative 1 over 3. So the whole thing is attached to negative 1 over 3. Okay, that's fine. So we know if we to simplify that, 9 minus 6 is 3 now. And then that whole thing will be x. 3 minus -3 will be 6 there. Okay, and then you are still attached to exponent there, which will be minus 1 over 3 there. Minus 1 over 3. So from there onwards now, the number that is outside will multiply everything inside now. So firstly, it will be 2, which we are having. So 2, the 3 that it has will multiply -1 over 3 now. So 3 times -1 over 3, that will come back as -1. So this 3 here will multiply the -1 over 3 first. 3 times -1 over 3 will give us -1 now. Same thing applies now. The 6 that is there on x will also multiply the number outside. So it will be 6 times -1 over 3. 6 times -1 over 3, and that will come back as -2 now. So that is the power rule, where the number outside multiplies everything inside. So that is that. And then can we simplify that? I didn't really say you must simplify it, but if you want to simplify it, you can just make everything becomes positive. So just take it like this and just take it downwards. Same thing applies, because remember now they are just gonna be same thing where you can have 1 over x to the power of 2. So you can leave your answer like that if you want, or leave it like that, is still fine, depending on where they're asking us. Even if you leave it like this, it's still fine, or you can just leave them as positive exponents if you want. Just leave them as positive exponents, but they didn't say anything about positive exponents, so it's fine. So that will be that for 2.1.1. Okay, so let's go to 2.1.2 now. 2.1.2 now. Okay, so we're given a to the power of n to the power of n. Okay, same thing applies that we did before now. So whenever you're given it like that, you can expand it first. You can expand it first if you want. So you're gonna have x to the power of n. So we're gonna expand it, x to the power of n times x to the power of 1, because we expand, oh sorry, x to the power of 2, we're expanding it, plus x to the power of n times x to the power of 1. We're also expanding it again. Okay, then minus x to the power of n. Okay, I think now that we're done with this part, I can just erase it there, because I want to end up mixing numbers from the previous question with the other ones. Okay, because it might end up causing a problem if we're mixing numbers. I want to end up mixing numbers. So just expanding everything so far. I haven't done anything drastic. Okay, so x that, and then minus x to the power of n times x to the power of -1. So I was just expanding the whole thing as it is, with no intentions of doing anything dramatic. So I think, yeah, that is that. And then the whole thing, remember, we're dividing it with it was x squared minus 1. So I don't want to change anything so far there, which I know is different of 2 squares, but I won't do anything so far. Okay, sharp. Then we check what we have now. We have a common factor again of x to the power of n. So we've got a common factor of x to the power of n because it's occurring a lot of times. So when it gets, the open a bracket, when it gets there, we know it will come back as x squared there, because it will be 1 times that, it will come back as x squared there, and then plus 1 times x to the power of 1, so it will be times, let me do this, here it will be 1 times that, it will be x to the power of 1 there, x to the power of 1 there, minus the same number, which is will become back as 1 there, minus 1 times and then times that, which will just come back as x minus to the power 4. X to the power of 2 plus 1. I made a mistake. Okay, it's fine. I'm just trying to erase this part. Just notice my mistake there. So it will be that plus x to the power of n, which will be 1 times that, and then 1 times that, which is x to the power of 1. It should be, yeah, so it will be that. So that's, let's see. It's 1, yeah, 1, and then that will be for the first part there, that, yeah, minus. Oh, okay, I see where I'm making the mistake. Okay, that's fine. Now I figure it out. So it will be this, and then with this one, and that one will give us -1. Yeah, it will give us -1 there, and then again we're gonna have a plus sign there, and then again we're gonna have another common factor of x to the power of n going to the other one, which will just give us x there, and then lastly minus x to the power of -1. Okay, you nearly made a big blind by not grouping them correctly. So I've grouped them now correctly, and then the whole thing you divide by what you already had, which was x squared minus 1. You nearly made a big blinder there, so it's fine. Okay, now that we've done that, it will make our life a bit easier. So now we check what drastic measures can be done here. What drastic measures can we do? Is there anything that will allow us x? Oh yeah, these two are the same numbers. This and this is the same, so they can cancel each other. Okay, that's fine. That makes our life a bit easier. So meaning if those two cancel each other, I'm only left with x to the power of n there plus x to the power of n again, which we know is attached to the other part, which would be x over that. Okay, which will be x. Wait, was it x? Yeah, it's x there, so it's gonna be x and over that. I'm trying to figure out what is going on here. Okay, fine. So it's gonna be that will be attached to the remaining part, which will be x to the power of 1 there. So it will be x to the power of 1 there. So it will be 1 to the power of x 1 there, and then minus 1 over x. Yeah, minus 1 over x. So something is, if it's kind of back there, it will just become 1. Okay, just become 1, and then 1 over x. 1 over x to the power of 1. 1 over x to the power of 1. So I can't do anything after that. Can you? No, I can't do anything after that. So I'll just leave my answer like that, because I feel like I can simplify from there onwards. Yeah, I don't think I can simplify from that onwards. So just leave it like that, because I can't do anything from there. So I'll just leave it like that, They didn't say solve for x, just asked to simplify, so it's fine. I'll leave the answer like that because we're just simplifying it. Perfect. So I need to make space for 2.1.3 now. I need to make space for 2.1.3 now. I need to make space for 2.1.3. Yeah, I've already passed 1 hour. It's a 3-hour paper, so I'm trying to make sure that I finish in time because now you're gonna end up running out of time in the exam room. Okay, so let's do 2.1.3 now. Just this one there. So we're given a lot of square roots now. So whenever we're given a lot of square roots, it shouldn't be a problem. So they're multiplying each other, those two square roots. So whenever the square roots are multiplying each other, we can just rearrange this whole thing now, and then it just come back as we've got a already there. We've already got a there, and then because they're multiplying each other now, so because they're multiplying each other, just put a bracket there with your a, so it'll be plus the other square root, which is inside. It's square root of 2a minus 1, because they're multiplying each other there, and then it's attached to one square root there, and then you close the bracket there. Don't forget the bigger square root there, and then open the second one because they're multiplying each other, so just become a minus second square root, which will be 2a minus 1 also. Okay, that's fine. 2a minus 1 also. So because they're multiplying each other, and then you close that bracket because they're multiplying each other now. So from there onwards, you can just simplify it further. So we know in math, when they're multiplying each other, this a here will multiply the a there first. Don't forget the bigger square root now. So the a there multiplies the a there. So when you come back as a squared now, because the a there will multiply the other a there. Same thing applies. The a that we have here will there go and multiply the second number, which is negative, that one there. And again, after that, I'll just put them down for you guys to see. So a will multiply that thing, so meaning it will become back as minus a square root of 2a minus 1 there. And then again, same thing applies. The second number now, which is square root of 2a minus 1, will multiply the first a here. So it just come back as plus now, because now it will become plus. It will become plus a, and then square root of 2a, square root of 2a minus 1 there. Square root of 2a minus 1, and then that will be that. And then lastly, it will be that plus 2 square root of 2a minus 1 multiplying the other number, so it will become minus there, and then the same number multiplying itself, so just come back as it's going to be squared now. Same number multiplying itself becomes squared, just put a square there, so it will be 2. Sure, my tool is so terrible. So it will be 2 a minus 1 there, 2a minus 1 there, and then squared there, 2a minus 1 squared. Okay, fine. So we know in maths that same number, different signs, they become 0. This and this will become 0 because the same numbers but different signs. So meaning now we are left only with square root of a squared, square root of a squared. I think we can save ourselves time now because it's going to also buy some time. So the square root of a squared will come back as it is, no problem there. And then we know that this one was squared. Any number squared will come back as the squared will remove the square root now. The other side was squaring it, so to take out the square root. So meaning this whole thing now, when it becomes simplified, it will come back as the square root of a squared now. Square root of a squared will come back as it is, and then minus this one here, square root is being squared, so to take away the square root, so meaning only 2a plus 1 will come back now. Only 2a plus 1 will come back. Only 2a plus 1 will come back. Okay. So from there onwards, we can factorize this whole thing in the square root. We can factorize the whole thing in the square root. So it's x squared minus 2a minus 1. So we know that must be two numbers. So the first number will be a there minus 1, was it a minus 1 there? And then same thing, a minus 1. So my two factors of that whole thing, a minus 1, a minus 1. My two factors of that whole thing. And then because it's a square root of the same number twice, so it just become square root of a minus 1 squared. So it becomes square root of a minus 1 squared because the same thing twice that we just did before. So just come back, it is a minus 1 squared, and because the squared can go away, and then our answer just becomes a minus 1. So that'll just come back as a minus 1. So the whole thing just simplifies to a minus 1. That's a nice question. So about just simplifying, square rooting, and then leaving the answer to the fullest. Okay, now let's do the last one, which is 2.2. Again, let me try to use this whole part, and then if something is not making sure, please comment in the comment section. Maybe I can just separate the questions and do them separate for you guys if maybe they don't make sense. So that will be that. So the last one, we're given that, and then we're being told that it's equals to that. Determine that the use of calculator the values of x, y, and z. So we're given that whole thing on the left side, and then also on the right side. Then we're being asked to find the values of x, y, and z. That's fine. So let's try to figure out what's happening here, so that we can make our life a bit easy. So we've got the other numbers which are attached to the other one. So x plus and x, y, and z are attached to the square root of 1 minus square root of 2 there. Okay, let's see that. Trying to figure out how to take this one out from each other. Okay, I think we can leave this one with x and y and z together. So meaning I can divide both sides by this. Let me divide both sides by that now. I'm trying to keep the other one by itself. This one with x, y, and z, because the one has to find x, y, and z. And I don't think I can do them separate. So let me just leave them together as they are already, x plus y, so that I can solve for them, because the aim is to solve for them. So I'll just leave them as they are, and I'll solve for them, because I can't do them one by one. Even for max won't allow me to do them one by one. So I'll divide both sides by this whole number, which is already there now. So if I divide both sides by that, so meaning it will be equals to, on the other side, we'll end up with negative 3. It's in a bracket, negative 3 plus square root of 2. So that's what I'm having on the other side. So now because I'm dividing both sides by other number, so meaning I must divide here by the number which I've removed the other side, which was 1 minus square root of 2. So I'm going to divide both sides by 1 minus square root of 2. Sharp. So I've divided both sides by it, and then meaning it will cancel the other side. So meaning x plus will only remain alone, because the same number divided by itself will cancel it. So I'm left with only this part, because these two will cancel each other. So only this part will remain. It's square root of z here. 2. Like my 2 looks like a z. My 2 looks more like a z. So it's gonna be z then. Okay. So from there onwards, we're still solving for this, which I'm gonna leave it like that now. So now the question is, how do we're dealing with surds. So remember, when you're dealing with surds, and whenever you have got a denominator, we can rationalize the denominator. And to do that, you just need to multiply the other side, but by a different sign now. So it'll be 1 plus square root of 2 now. Just need to multiply the same thing twice, but just change the sign when you're doing the surds. So it'll just become 1 plus that's now square root of 2, because I'm doing the rationalizing the denominator. Okay, that is fine. So now that I've done that, this will make our life easy. The numbers which are on the numerator are going to multiply each other. So meaning first, just put them in the bracket there, because it will make your life a bit easy when you put them in a bracket. So it will be negative 3 times 1 first, and then also negative 3 will multiply the square root of 2 ne? And then same thing will apply when you do the other side. So it will be negative 3 times 1, which will give us negative 3 ne? Then negative 3 times square root of 2 will give us its plus sign there, 3 no negative sign there, not plus, give us negative sign because it's negative 3, so it will give us a negative sign there because it's negative 3. So it will be minus 3 root 2, and then we continue. Square root of 2, now we'll multiply the 1 there, so it will be plus square root of 2 there, so plus square root of 2 there, and then lastly square root of 2 times square root of 2 will come back as 2 now. And then the whole thing you divide by, again it's 2 brackets, again bracket there and bracket there. 1 times 1 will be 1, 1 times square root of 2 will be square root of 2, because 1 times square root of 2 will be square root of 2, and then negative square root of 2, and that will be minus square root of 2, and then lastly negative times that will give us negative 2, yeah, and then here everything will remain as it is. That's x plus y plus square root of z. So I'm not going to change anything there. My aim is to simplify the other side. Square root of z. Fine. Let's try and make some space and get space for that. So now we just look for like terms there. So now we just look for like terms there. So let's just look for like terms. So it will be negative 3 and plus 2. That will give us negative 1. Numbers will give us negative 1, because it will be negative 3 plus 2. That will give us negative 1. And then negative 3 root 2 plus root 2, same thing as negative 3 plus 1. That will come back as minus 2 root 2. To come back as minus 2 root 2. Come back as 2 minus 2 root 2 there in my numerator. Then over here, when I have 1 minus 2 will come back as minus 1. And then same number, different sign, they cancel each other, meaning this and this will cancel each other. So that will be that. So meaning we're left with negative 3. So it was negative 1. So only for that part now. So the whole thing that you are looking for, let me just do this. The whole thing that you are solving now, the x plus y plus square root of z, plus square root of z plus square root of z plus square root of z is equals to that. Now that I've simplified it, and then we just continue now to simplify. Remember, this whole thing now you divide by negative 1. Negative 1 divided by negative 1 will give us 1, and then because our aim is to divide the whole thing by negative 1. Negative 2 over 2 root 2 divided by negative 1 will give us plus 2 root 2, because the whole thing divided by negative 1 will come back as 2 root 2. So meaning that is what we are having as our x plus y plus square root of z. That will give us that, which will be 1 plus 2 root 2. So it's 1 plus 2 root 2. Yes. And then they're asking us to find values of x, y, and then z. So that's what we were having before. Oh, unless if I want us to find some, but there it was in the bracket, and then it was giving us that. And then with 3 numbers. Oh yeah, now I see. Oh, this whole thing, look, this and this look the same. Oh, nice. I didn't have noticed that actually. This, look at this and that, they look the same. So meaning the first number we have is 1, there it's x. So meaning when we need to simplify it again, x will be 1. The first number we're having here is 1, so meaning x is 1. And then plus. The second number that comes after plus is y. Y there we're having 2. So meaning y is 2. It's the same thing now, so that we are showing it that way. Then lastly we have a number in a square root, which is z here. Here the number was z, but here the number is what? Is 2, meaning z must be 2. So those are the values of x, y, and z. Wow, that's so nice. Reminds me of first year algebra, where we compare left and right side. Wow, that was a nice question to see. So that will be y, x, y, and z. So x is 1, and then y is 2, and then z is 2. Lovely, lovely, lovely. Now let's go to question number 3, which is a different topic altogether. So it's number patterns now. We're given an expression, tan x, sin x, and cos x. Okay, for 3.1.1, explain how each term is found in the previous term. Okay, that's fine. How each term is found in the previous term. It's tan x, sin x, and then cos x. How can we? What's the common link here? We've got tan x there, sin x, and then sin x, and then cos x. Okay, it seems like okay, figure out this. Trying to figure out. So it's tan x first, then we go to sin x, and then after then we go to sin x cos x. What's the common ratio here? Because the aim is to find out what is the common. Because the pattern, if the pattern is linear, because if it's giving us a linear pattern. So one thing I'm seeing that we have tan x first, then we have sin x as my number 2. My third equation is sin x cos x. How each term is found. If I do tan x times cos x. Okay, so far second term is this, and then to find the third term we're multiplying by cos x. So to find the, okay, let me do this, because for us to find t3 we multiply t2 by cos x. If I do that now, let's say my t1 is tan x, that's my t1 is tan x. If I were to multiply this by cos x, let's say I multiply this by cos x, let's say I multiply this by cos x and see what it will give us. Multiply this by cos x, that's my t1 tan x. So I'm multiplying this by cos x because I'm saying that t2 was multiplied by cos x. Let's see if maybe t1 also was multiplied by cos x. Let's multiply this by cos x. We already know that sine is the same thing as tan is the same thing as sin x over cos x. That's what we know about tan in trigonometry. So same thing as sine over cos. So meaning whenever you see tan, just change it to that. So if I'm applying, remember we're applying everything by cos now to test what we saw with t2 and t3 now. So if I'm applying this by cos, and then we know that the number here and the number there will cancel. So meaning we end up with sin x. So from t1 was tan x. For us to form t2 we know is sin x. For us to form t2 here, they multiply t1 by cos x, which makes sense. Look at t3. t3 is sin x cos x, meaning for us to go from t2 to t3, they multiply t2 by cos x. So now they're asking us how each term is being found. We are multiplying by cos x. That will be your answer here. We are multiplying previous term by cos x. So we're multiplying previous term by cos x for us to get the next term. So for us to get the next term here, you multiply the previous term by cos x. So t1 was tan x. For us to get t2, they multiply tan x by cos x. Then we got t2, which was sin x. For us to get t3, they multiplied sin x, which was t2, by cos x. Then that gave us sin x cos x as our t3. So for us to find the next term, you multiply the previous term by cos x. That will be your answer for 3.1.1. You multiply the previous term by cos x for us to get the next term. That was a lovely question. I feel like it required a lot of thinking, but it's just nice for the brain. Okay, write down the fourth term or the t4. So remember now t3 we already know it's given to us. It's sin x cos x. That's our t3. It's sin x cos x as our t3. Now we are being asked to find t4. So we know for us to find the next term, you multiply the previous term by cos x. So meaning you must multiply our t3 by cos x. We need to multiply our t3 by cos x for us to find the t4. And if we to multiply this by cos x, we know that sin x will remain the same. So it will be cos x times cos x. We know that will come back as cos squared x. That will come back as cos squared x. That will come back as cos squared x. That will be our t4. So t4 will be that. That will be our t4. So our t4 will be that, because we're multiplying previous term by cos x. That will be our t4. Okay, that is that for 3.1. I feel like there was a lot of thinking and a lot of learning for 2 marks. Maybe they reduce the marks so that they can be lenient, in case people don't figure it out. But I feel like there was too much work for 2 marks. Should be increasing the mark for such questions. I feel like they require more thinking and more planning. That's fine. So let's go to 3.2 now. Now we're given numbers. So when we're given numbers, it becomes a bit easy. So t1 is negative 1. Then we go to 2. Then we go to 5. Then we go to 8. Okay. Then determine an expression for the nth term for this pattern. So let's just look at the number that's given to us. It's negative 1 there. Then we go to 2. And then we go to 5. Then we go to 3. So let's look at the difference. Difference between there and there is 3. The difference there is t2 minus t1 will give us difference of 3. Also here the difference is 3. Also here the difference is 1 to 3. So it's a linear pattern or it's an arithmetic pattern. So to find the tn, so to find the tn now. So remember the tn of a linear pattern or number or arithmetic sequence. The formula is also given in the formula sheet in grade 11. So it's a plus n minus 1 d. That is a tn formula to use. A plus n minus 1 d. And then if you're not familiar with this, please check my playlist which I've done on number patterns in grade 11. So d is the common difference, and our common difference here is 3, which you find by t2 minus t1, t3 minus t2, t4 minus t3, and so on. So d is 3 as our common difference. So therefore our tn, a is the first term in the sequence. The first term in our sequence here is minus 1. That's our first term in the sequence, which is minus 1. So a is minus 1, the first term in the sequence. That's minus 1. Then plus, you open a bracket there. N is what we're gonna simplify. So it'll be n minus 1. Difference is the d that we know is 3. Difference is 3 now. So from there onwards, it will be tn. It will be negative 1. That will be there. And then it's going to be 3 times n first. So it will be negative 1 there. 3 times n will be 3n. 3 times n will be 3n. Then 3 times negative 1 will be minus 3 now. Minus 3 now. So from there onwards, this will come back as 3n there. So we end up with 3n. The numbers is negative 1 minus 3. That is minus 4. Negative 1 minus 3 is minus 4. So the tn will be that. That will be the tn for that. But they're asking us to find the tn. Yeah, that's our tn for 4 marks. Okay, I thought it would be, but it's fine. That's for 4 marks. That would be a tn. Wow, okay, I didn't expect that to be 4 marks, but yeah, I feel like I did less than what I did with 3.1. I had to figure out what they were doing to find the sequence, but it's fine. That will be tn for the first one. 4 marks. Okay. Which term of the pattern will be equals to 161? So whenever they're asking you to find the n, you just need to equate the tn that we have with the last number, which is 161. So you go and equate this with 161. So it'll be 161 will be equated with the number that you are being asked, which is 3n minus 4. 3n minus 4 there. Then you go and solve for n. So the negative 4 will jump the other side. It will become plus 4. So 161 plus 4 will be 165. And then the whole thing you equate with 3n. Then the aim is to find n. So just divide everything by 3 because the aim is to find n. Divide this by 3. And then please, if you're not familiar with this, please check my playlist list. I've done a lot of questions about this. which I think will help you guys to figure out this type of questions. So 165 divided by 3, it's 55. So the number that they're asking us is what? 55. That'll be your term of the sequence, is 55. Then let's continue to question number 4. The diagram, the first 3 figures of the pattern that Mary is investigating are shown. Okay, figure 1 has got 4 dots. Figure 2 has got, it's 9 dots. Okay, then 3 it's 16 dots. So let's just put them down. We've got 4 for figure 1, and then we've got 9, and then we've got 25. No, 16, sorry, 16, and then based on that ratio, it's 2 squared, 3 squared, 4 squared. So I mean the next one must be 5 squared, which will be 25. Based on that pattern, is 2 squared is 4, 3 squared is 9, 4 squared is 16. Meaning the next one will be 5 squared, which will be 25. So they're asking us to find the total number of squares in figure number 5. Okay, figure 1. So they want us to find how many total number of squares. Okay, the first. So okay, the dots. Okay, here we are. Here I was putting the dots. So the aim is to find the squares now. The first 3 figures investigating as shown. Total number of squares. Here we're gonna have, I think I can get 1 square there. 1, 2, 3, 4. I can get 4 squares here. Here I can get 4 squares here. 1, 2, 3, 4, 5, 6, 7, 8, 9. I can get 9 squares here. Meaning in number 4, same pattern again. 1 squared is 1, 2 squared is 4, 3 squared is 9. Meaning in figure number 4, you're gonna have 4 squared, which will be 16. Then figure number 5, you're gonna have 5 squared, which will be 25. Meaning in figure number 6, you're gonna have 6 squared, which will be 36. And so on and so on. So meaning the squares which will be there in number 5 will be 25. But the dots which will be there will be, just be careful, the dots would have been 36. But they're asking for squares now. Squares will be 25, but dots will be 36 if they're asking for dots. But because they're asking for squares, it will be 25 for that one. Then how many dots? Now they're asking for dots. Just be careful of that. Here, just put them down. This is for dots. This is for squares. It's very important to put the difference. For squares, we know. Sorry, for dots, here we had 4 in the figure 1. Figure 2, we know it was 9 dots. Figure 3, we know it's 16 dots. Figure 4 will be 25 dots there. So just be careful of that. For dots, we know in the first figure we've got 4 dots. Second figure, we've got 9. Third figure, we've got 16 dots. Meaning figure 4 will have 25 dots. Figure 5 will have 36 dots. Figure 6 will have 49 dots. Meaning this will be the sequence. Figure 1 we know it's got 4 dots, which will be 2 to the power of 2 now. Second one will be 9, which will be 3 squared. And then from there onwards you go to 16, and then you go to 25 because it's just been squaring each other. Then you go to 36 from there onwards. That'll be the pattern for dots there. Then for squares will be the one we just did now. Then it'll be 49 there. Then from 49 we go to 64, and then from there we go to 81. That'll be the pattern of the dots that you'll be getting for each corresponding figure. So meaning now they're asking how many dots are in number 7. 1 is 4, 2 is 9, 3 is 16, 4 is 25, 5 is 36, 6 is 49, 7 will be 64. So meaning you're gonna have 64 dots in figure 7. That's for dots. But for squares will be different. Don't forget me. For squares will be different because figure 1 has got 1 square. Figure 2 has got 4. 3 will have 9. 4 will have 16 squares. 5 will have 25 squares. 6 will have 37, meaning then 7 will then have 49. So it will be the pattern as it is for squares and dots. Just be careful of that, what they're asking me. So considering the n figure, show that the expression for the number of dots can be written as that. So they want us to find the expression for the dots. So remember, the pattern for dots we know. The first 10 for dots is 4, then it's 9, 16, and 25. So meaning we can do the sequence and see what's happening. The first number is 4, then we go to 9, then we go to 16. That's the sequence we're getting for dots. The difference between there and there, we know it's going to be 5. Difference between there and there, it's 7. And we know that we can go second difference, which will be 2. So meaning the dots are giving us a quadratic sequence. Again, if you're not comfortable with this, please check our playlist. We have covered a lot of quadratic sequence and how they operate. So meaning these dots are giving us a quadratic sequence. So to find the Tn of quadratic, so remember you first find A. To find A, you do 2A is equals to the second difference. Second difference in this sense is this one. These values here, they are our first difference. Then this one becomes your second difference. So it will be 2A is equals to second difference, which will be 2, because our second difference is 2. Then the aim is to solve for A, so we divide everything by 2, because the aim is to solve for A. So 2 over 2, we know to come back as 1. So meaning A is 1. So the A value will be 1. Then from there onwards, you find your. I'm just trying to erase this. I feel like you can move this now, because they don't add any value to anything. They don't add value to anything. These numbers now. So to find B now, it will be 3A plus B is equals to T2 minus T1. 3A plus B will be equals to T2 minus T1. T2 minus T1, we know it's 5, because that's T2 minus T1. It's this value here, it will be 5. And then A we know is 1, so 3 times 1 is 3. So we'll come back as 3 there, plus B. 3 plus B is equals to 5. Then aim is solve for B, so meaning B will just come back as 5 minus 3. So B will come back as 5 minus 3. So B will come back as 5 minus 3, which we know that will be 2. So meaning otherwise our B is 2. Our B is 2. So our B will come back as 2. Then lastly, we need to find C. To find C, we do A plus B. A plus B plus C is equals to the T1. So it's A plus B. A plus, so it will be A plus B plus C. It's A plus B plus C. So it's A plus B plus C, which is equals to T1. And T1 is the first number which we have in the sequence, which is 4. And again, please guys, please check the playlist, so at least you can get used to this type of questions. A we know is 1. B we just found is 2. So it's 2, and then aim is to find C now. So it will be that, and then the whole thing is equals to 4. 1 plus 2 is 3. So it will be 3 plus C there. So meaning C will be 4 minus 3. So C will be 4 minus 3 when you take everything to one side. So C will be 4 minus 3. Then C is 1. So C will become back as 1. So C is 1 there. Now that C is 1, we're going to put everything in the Tn. So Tn of quadratic, A we know is 1. B we know is 2. So it's an squared. So meaning to come back as A, it's an squared now. The Tn of quadratic is an squared plus Bn plus C, plus Bn plus C, then plus C. So A we know is 1. A we know is 1. So meaning if we simplify this, it will come back as n squared there. So it will be n squared. B we know is 2, so it will be n squared plus 2n. Okay, let me not squeeze it there, because now it's looking a bit dodgy when you are putting things in a small place. So let's do this now in a very much clear place. So our Tn will come back like this. So our Tn now will come back like this. So it will be n squared because a is 1. So it will be n squared plus b we know is 2n, c we know is 1, c we know it's 1. So that will be our Tn. Yeah, that's our Tn. We are being asked to show it like that. Okay, just need to factorize this now. So we know that to factorize this, that's our Tn there. To factorize this now, we know that it's the same thing as putting, yeah, it's 2n and it's 1. So it's the same thing as n plus 1 squared. So when you expand n plus 1 squared, it will take you back to when you expand this, it will take you back to that. So this is the same thing as that, which they're asking us to leave the answer as. Okay. Then let's go to 4.2 now. So now we are given an information. An athlete runs along a straight road. His distance d from the fixed point p on the road is measured in difference, and then we're given the dn of that. Okay, so we're given time 1, 2 until 6, and then we're given distance which is measured. There's an r and x which is given to us there. Okay, that's fine. So whenever we're given this now, we're asked to find the value of r and also the value of z, yeah, of x. So now let's figure out what's happening here. So we're given 1 is 17. So we have 1 is going with 17, 2 is going with 10, 3 is going with 5, and then 4 is going with 2. Then we're being asked now what 5 will be going with. So let's look at the pattern here. So we've got 17 there, and then we've got 10 there, and then we've got 5 there, and then we've got 2 there. Then the other 2 are missing. So one thing I'm noticing here, it's 1, then we've got 2, we've got 3, we've got 4. So it's just adding by 1. So from this so far, we have a difference so far here. T2 minus T1 will be minus 7. So we've got minus 7 is the difference here. Same thing applies. The difference between this one and this one is minus 5. So we've got difference of minus 5 there. And then from there to there, we have a difference of minus 3 as our difference. Okay. And we know if we're to continue with second difference, this and this will give us 2. And then this and that will also give us 2. So meaning the difference that's coming here also should be 2. And the difference that's coming there also should be 2. So now here it's minus 3. So meaning if we're to continue, the next number must be minus 1 there for us to give us a difference of that. And then again, this will be 1. So that will be the next 2 differences for us to end up with 2. So they were asking us to find these 2 guys here. So now, so far we know that it was 17, 10, 5, which are from these numbers. And then the difference between this and this is minus 3. But the difference between this one and this one is minus 1. Meaning here it must be 1 if the difference is minus 1. And then here the difference is 2. Meaning here it must be, so it's 1, meaning it must be 2. So that will be the next number there, which will be 2. So now we have figured that out based on the differences. So meaning the 2 numbers they're asking us to find are these 2. It's 1 here and 2 there. So meaning R here is this one. So R must be 1, and then this one will be 2, S2, based on this sequence that I've done. So one thing I did was just to use the differences which I can get from these 2 numbers now. So I got the differences which I got, and we know that we can continue with the same pattern and get second difference which we got of 2 now. And everything must be 2 throughout if second difference is the same. And then to find out number that will give us 2, here it was negative 1, here it was 1. So and then we know that for that to append, this must be 1 for us to get a negative 1 as our difference. and then here must be 2 for us to get a 1 divided of 2, meaning r is 1 and then s is 2, which is fine that way. So from there onwards, now we're being asked to find the values of a, b, and c. Okay, now they're asking us to find the values of a, b, and c. Why is O and b and c are here? So basically they're asking us to find the Tn of this quadratic sequence. That's fine. Okay, we already know the sequence. The second difference is 2 throughout. So again, same thing that we did before. We need to find the value of a first. A, we know to find a, you do 2a is equals to second difference. Our second difference here is this one, which is 2. So it will be 2a is equals to 2. And then again, same thing, divide everything by 2. Because the aim is to find a, divide by 2. So meaning a is 1. So our a will be 1 because the aim is to find our a. Then from there you go and find b. To find b will be 3a plus b is equals to t2 minus t1. So t2 minus t1 will be this value here. That's our t2 minus t1, which will be minus 7 in this instance. So it will be minus 7 in this instance. That will be minus 7 in this instance. And then that will be that. So from there onwards now, yeah, so let's check. They want us to find let's find, we want to find a, b, and c. Wait, did I even check this clearly? And then there's a distance, okay, distance of that, which is fine. And then let's find b now. So it will be 3 there. A we know is 1 there, so it will be 3 times 1 there. Then plus b, and then the whole thing is equals to minus 7 there. The whole thing is equals to minus 7. And then the aim is for b, so meaning it will be b there, and then it will be minus 7 minus 3. So minus 7 minus 3, because 3 will jump the other side. So meaning b is minus 10. So b is minus 10. So b will be minus 10 there. So b is minus 10. So b is minus 10. That's fine. So we have found a. They're asking us to find a, b, and c. A is 1. B we know is minus 10. So now we need to find c lastly. To find c, you do a. To find c, you do a plus b plus c. So it will be a plus b plus c, and then the whole thing is equals to t1, which is your first term. T1 here is the first term, which is 17. So t1 will be 17 as our first term. A we know is 1, b we know is minus 10, and then plus c, which you are looking for. Plus c, which you are looking for. Then the whole thing is equals to 17. The whole thing is equals to 17. So 1 minus, so the whole thing is equals to 17. 1 minus 10 is negative 9. So this will c will just become 17. 1 minus 10 is negative 9. So it will be 17 plus 9. Because negative 9 will jump other side and becomes plus 9. So c will be 17 plus 9, which will become 26. So c is 26. So we found all those values, a, b, and c. That's fine. Yeah, that's fine. So we've got all those values now. Bang. So let's go to, that was for 4.2.2 now. So now let's go to 4.2.3 now. Now let's go to 4.2.3. 4.2.3 now. 4.2.3. 4.2.3 now. Okay. How far is the athlete from P where n is equals to that? Okay. So we already have the Tn in this instance equals the Dn. So we know the Tn that we have, a is 1. So just come back as n squared because a is 1. Then b we know as minus 10. So it'll be minus 10n there. So it'll be minus 10n there. And then c we know is 26. So it'll become plus 26. Become plus 26. So that will be our Tn that we have there. So from the Tn that we have there, we've been told that n is equals to 8. So whenever you see n, put 8 now. Because n, we've been told that n is equals to 8. So we're going to put 8. There's an n there. So I'm going to put an 8 there, which will become 8 squared now. And then minus 10 there. There's a minus 10 there. So again, same thing. We'll put an 8 because there's an n there. And then plus 26. So then now we are being asked to find the value of that. So our answer will just become 8 squared minus 10 times 8 plus 26. That will be what we are looking for. So it will be 8 squared times 10 minus 10 times 8 plus 6. So yeah, it's giving me 10. I'm getting an answer of 10. So that will be our answer for this. So it will be 10. That will be 10 for that. Okay, so let's do the last one here, which is 4.2.4. I think I'm going to separate the video now because I'm seeing that I've done close to 1 hour 50 minutes. So I don't want to make a video that will be 3 hours. So I think I'm going to do part B for the remaining questions so that at least I don't have to do a long video, because most people were complaining that they don't have the interest to watch a long video. So I think I'll try to break it down and do other questions in a separate video. At least that will make it 2 parts. 4.2.4. Michaelia claims that the pattern will have a minimum value. Jack claims that the pattern will not have a minimum value. Who is correct? Okay. So we know about minimum and also maximum. So here Michaelia is saying it will have a minimum, and then Jack is saying no. Okay. So let's find the minimum turning point of this, because we already have the Tn already, which is that's our Tn. So to find the minimum value, remember, is that concept where to find the minimum of turning points, so it will be TP for turning point. So to find the turning point of the minimum value, that point where you do negative b, then you divide by 2a. So you do negative b, then you divide by 2a. So from there onwards, it will be negative in the formula. The value of b that we have there is minus 10. The value of b we have is minus 10. And then you divide the whole thing by 2 times a. A we know is 1. A we know is 1. So it will be negative times negative is positive. 10 divided by 2 is 5. So meaning the x value that you are having there is 5. So we're having an x value of 5. So we have got an x value of 5. That is the turning point x value. Just put as x turning point there. It's 5 now. So now to find the corresponding y value, you put wherever you see n, you put 5. So it will be 5 squared on our Tn there, 5 squared minus 10, open the bracket, there's an n there, you put 5, and then plus 26 there. And then if the value we're getting here is positive, therefore it's maximum. But if we're getting a value of negative, therefore it will be minimum there. So let's see how much we're getting. So the other way around, just show them the other way around. So now we can end up getting, let me get the value that we're going to get here. So it will be that 5 squared. So I'm getting the corresponding y value of 1. So y value that we're getting is 1. So we had an x value of 5, but the corresponding value is what? Is 1. So the question was, will the pattern have a minimum value or a maximum value? So now the question is, our corresponding value is 1. So we're getting a y value of 1. So this is how this can look like. The corresponding value is 1. So if that's the case, now we're getting a y value which will be 1. So Now, between Jack and Mikalia will be correct. So we can see that we're getting a y value of 1, meaning Mikalia was correct because the corresponding n value we're getting is above 0, which is 1. So we're getting a positive value of 1. So Mikalia is correct. So as conclusion, you will say Mikalia is correct, which is correct because we're getting the minimum value. So Mikalia is correct. That will be the conclusion. Mikalia is correct. So when you conclude this, we will say that Mikalia is correct. So this, what we're doing here, we just to back up statements that will get a minimum value. So whenever you get a y value which is positive, then it will give you a minimum value. But if you're getting a negative one, it would have been the maximum value. So Mikalia is correct. So like I said, I'm gonna do a separate video where I'm gonna do question 5 and 6 and 7, which will be the remaining part of this paper. And then yeah, so please check out for part 2 if you want to continue with the paper. Thank you very much, and don't forget to check the playlist now. Thank you.